This is a grade 9 star question. It goes, a car drives away from a set of traffic lights. The velocity time graph gives some information about the motion of the car. So, first of all, copy the graph, draw a chord between 0 and 10. So, that's what I'm going to do with that. I'm going to draw a chord between 0 and t equals 10 seconds, which will be about here. Okay, now, once I've done that, there's 10 seconds. Just going to bring that down. Now, we've done that. Calculate the average acceleration of the car over 10 seconds. So, that's gone from there to there, 10 seconds, and that's gone up. It's gone to, if I draw a straight line from there, again, you should do this with a ruler. That looks about 28, I think, 25, no, 29. So that's about 28, 29. I'm going to call it 29 meters per second, and that is 10. So the average acceleration is going to be velocity over time. So it's gone 29 meters per second over, taken 10 seconds to do that. And that will give me 2.9 meters per second per second. Okay, so that's the acceleration from there to there, the average acceleration. Then it goes, estimate the acceleration at t equals 4. So this is known as instantaneous acceleration. Okay, so we're going to draw a tangent at this point. We'll go there. So again, we'll go, get me tangent drawn, going, I'm going to go from here, and I'm trying to do it so that I can make it to a nice phone number out there. Okay, now that gives me a tangent from there. If I went up from here, just drawing this, and I go along here and here. So I should run. I've gone from 15 seconds all the way up to 29. So that gives me 14 up here, and along here I've gone from 2 seconds all the way, and if I draw that line going all the way down, so I've gone from 2 seconds to about, very well, if I stretch this slightly and make it exactly 8, I'll get that to, yeah, I'll do that. So that will go from 15 to 30. That's gone 15 seconds, meters per second up, and that's taken from 2 seconds to 8 seconds. So that's going to give me 6 seconds. So for C, an estimate for the acceleration at t when t is 4 seconds, it's going to be 15 meters per second divided by 6 seconds. That's my acceleration, and if I do that on the calculator, I'll get 15 divided by 6, which is about 2.5 meters per second. Okay. Now, D, describe how the acceleration changes over to 12 seconds. So if we describe it, how the acceleration, so the acceleration seems to be up, and then after 12 seconds it slows down. It's starting to slow down here. So describe how the acceleration changes over 12 seconds. You speed up, and then the acceleration kind of slows down. It's kind of comes to a halt of acceleration. It then becomes like almost there, where the speed becomes constant. So if I was to describe that, how the acceleration is slowing down. Okay, so acceleration is decreasing. It increases, acceleration, let's say, increases, and then starts to that. So that is where you get constant speed or velocity. And then it goes here, estimate the displacement of the car between 4 and 8 seconds. Now what I'm going to do is, before I do this, I'm going to rub all this annotation off. So there, and if I get rid of these lines, because I'm going to have to draw. Okay, so what I need to now do is I need to draw estimate displacement between these two. So what I'll do is I'll get a straight line drawn, and I'll go between 4 seconds and I'm going up to 8 seconds. It's about there. Then I'm going to just draw that straight down. Okay, and draw this one straight down. And that's a bit out. Eyes are deceiving me, so that's fine. If I go there, what we'll do is pick this up slightly and bring it here. That's okay. That's fine. So displacement between that is basically telling me to work out the area underneath this graph. So from there, that is going to be 20, and if I look along here, that's going to be about 26, and because it's a trapezium here, and that's going to be 4 seconds between there and there. So to get the displacement, which was E, top at the bottom, 20 add 26 times it by 4 shared by 2, so that plus that is 46, and I'm going to be multiplying half of 4 is 2, and 2 times 46 is 92 meters. So that is the displacement from between 4 seconds to 8 seconds. So that means you've gone further for 92 meters from where you had started at the traffic lights. And because it discussed displacement and distance travelled, what displacement is how far you are from your original position, and it is different to displacement if you're coming back. Okay, if you start to come back, your distance will double, whereas your displacement will become 0 as you come